Should we keep going? We're so close. 23. Day 23, safe cracking. This is one of the top floors of the nicest tower in Easter Bunny headquarters. The Easter Bunny's private office is here, complete with a safe hidden behind a painting. And who wouldn't hide a star in a safe behind a painting? That's right, we're collecting stars. The safe has a digital screen and a keypad for code entry. A sticky note attached to the safe has a password hint on it, eggs. The painting is of a large rabbit coloring some eggs. You see 7. When you go to type the code, though, nothing appears on the display. Instead, the keypad comes apart in your hands, apparently having been smashed. Behind it is some kind of socket, one that matches a connector in your prototype computer. What's my prototype computer? Oh, I remember this one. I didn't realize I was making a prototype computer. All right. You pull apart the smashed keypad and extract the logic circuit, plug into your computer, and plug your computer into the safe. Now you just need to figure out what output the keypad would have sent to the safe. You extract the assembunny code. Is that also day 11? Oh, no, that's day 12. Oh, yeah, okay. So are we reusing assembunny? The code looks like it uses almost the same architecture and instruction set that the monorail computer used. Right. So this is day 12. We had these instructions. So that means we need to refactor, maybe? Let's find out. You should be able to use the same assembunny interpreter. Okay, for this, as you did there, but with one new instruction, TGLX, toggles the instruction X away. Pointing at instructions like J and Z does. Positive means forward, negative means backwards. For one argument instructions, ink becomes dec, and all other one argument instructions become ink. I'm trying to think, okay, now we have to modify our program in place. And the assembunny code we created is not set up for that. If I look at, oh, that's the input file. This guy here, what we did was we created these 4 instructions. Oh, there's only 2 of them that have one argument. Oh, I guess TGL now has 1 argument. Does that count? We can extend this, but then we're going to have to make it toggleable. And the question is, do we just copy this code and then reuse it and modify it there, or should we try to refactor so we can pull this out and then reuse these lines? Here's a parser for it. Oh, this was a that was a test input. Oh yeah, so it has a built-in parser even. Okay. But then we have to be able to modify things, right? Because we say, you know, self VM run, self VM prog push, and then we end up with the machine has to have a mutable vector if we're going to be toggling instructions. For 2 argument instructions, J and Z becomes copy, and all of the 2 instructions becomes J. Ooh, there's a typo here. It should be all of the 2 argument instructions becomes J and Z. The arguments of a toggle instruction are not affected. If an attempt is made to toggle an instruction outside the program, nothing happens. If toggling produces an invalid instruction, like copy 1, 2, oh, I guess copy always takes a register destination. Yeah. An attempt is later made to execute that instruction, skip it instead. If TGL toggles itself, for example, A is 0, toggle A would target itself and become ink A. The resulting instruction is not executed until the next time it is reached. Okay, so this is, how do we, I'm trying to think of how to do this based on this machine, because that's going to be painful. You can't just flip it and then, because if you're going to toggle it and then what if you toggle it back, right? We can't lose data on the toggle. I can't just change invalid copy commands to no ops, for example, because then we need to be able to restore it. Oh, well, yeah. Because if you toggle a copy, toggle JNZ into an invalid copy, then you toggle a copy, it has to become a valid JNZ again. Huh. I mean, doing this should be straightforward. It's just trying to figure out a good way to do it is not something I can do off the top of my head here. I'm trying to think if maybe we can have each instruction have a tag on it, right? Because a program is just a vector of instructions. If the instruction itself has some sort of a tag to say, oh, I've been toggled, and then down here is where we execute the commands. We'd have to say, oh, are we working on a toggled command or on an actual command? Does this have tests? I did not write any tests for this. Okay. So if I break it, I break it. Cargo run 2016-12. So those are the answers it came up with last time. Maybe I save those off into a original day 12 answers. There. And that way we can compare to make sure that I don't break anything. Because if I'm going to refactor this, first of all, can I create a lib file inside AOC 2016? There's currently a mod in there. So if we just create like asm.rs cat source bin run AOC 2016 12, and we only need that and this and this. Here's the registers. There's the machine. And if we blow all of that away, so now all we have is the machine, right? And then we have to pub all these things. Oops, pub. Source doesn't have to be pub. Oh, it does because we have to, oh no, parsing is internal. This has to be pub. And then there's register. Machine has to be pub. Run has to be pub. And then in the mod, we should be able to say mod asm. Use asm star. All right, we have 22 warnings because we're not using anything. Oh, that's a private and public. Okay, so we do need to make source public. Now we're down to 20 errors. Register has to be public as well. Now we're down to 16 errors unused. Okay, so now if we go to day 12, 16, 12, I should be able to say use crate ASM star and comment all of this out. Maybe? Oh, create 20 AOC 2016 ASM star. Did I blow away the wrong thing? Oh, I did. Okay. This goes here. And then it doesn't like this. Oh, that's a private field. So I can put a push instruction on there. That'll help, right? And then this use ASM is unused. Okay. So I go back to the mod here. I don't need, I can say mod ASM, but I don't need to use it. And then here we can add a push instruction. Pub fun push, not self. Inst self prog push inst. And then push. Oh, jeez. Push. So now this should be able to work like this, right? Yeah, okay. So that's been refactored. Get status. Cargo run 2016-12. Let's see if it comes up with the same numbers. I didn't break anything. Okay, so that's good. Oh, and that was Clippy. Yeah, that makes sense. Okay, cargo. No, git add source. Because now we have this new ASM thing. Git status. Git commit refactor SM bunny computer for general use. Okay. So now all we need to do is modify this, modify the SM bunny code to be able to toggle so each one of these instructions needs to know if it's toggled. Bool. This seems like a weird way to do it though. And then when we push, when we parse the instruction, we need to be able to put a false in there, right? And then it should still run the same way. Oh. Yep, and then if I run this, it should still run. And it still comes up with those answers. Good. Okay, so now we have to be able to figure out, are we toggling these instructions? And if so, what do we need to do differently that'll allow us to do this stuff? We should get the input. Let's do that. This is day 23. I haven't even set up day 23 yet. Let's set up day 23. Oops. This one here. There we go. 23. 23. We're almost done. We only have 2 days left. What? Day 23. After we do this one, I mean. Oops, that said mud. Mud. Let's change that to a mutt. And then this needs to be what happened here? There we go. AOC 2016 day 20. Oops. 2023. Oh, I messed up. Let's try again. All right, so let's see if we can do it correctly this time. 23. There we go. And now I want to see, can I just do this? Because if I can, then I'll add that to my Altisnip thing. Oh, I forgot this one here. If I do a derive default, and that way, if I add something to this thing, it'll automatically, yeah, it kind of works, but it says it has no effect, so that's kind of annoying. But it runs. All right, so let's live with this for now. Let's get the input. Get input 2016-23. It's not very long. There we go. All right, this program isn't very long. It doesn't have a toggle. It has a toggle right here. That's the only toggle. Okay, but C will change throughout, right? So it's not like we're just toggling one instruction. We're toggling just about everything. So we need to extend our machine now to support the toggle instruction, which would take a source, which is a register or a val. Maybe source is the wrong word for it, huh? It's a destination in this case. And then we're going to add this here, TGL, inst, copy. Oh no, I was just looking up here. TGL, false, source parse, top 1. All right. Oh, yeah, that's true. Okay, and then for now what we'll do is we'll ignore it. Inst TGL source, and I'll just say println toggle source. There. Day 12 should still work. It does. So in order to toggle an instruction, we have to be able to mutate the actual instruction we're dealing with. And I don't know if we can do that here. Let's find out. Let's find out by doing 2016-23. Oh, which I never created? I must have... Oh, I didn't add it to the Git yet. Oh, did I forget to... No, I committed those changes, didn't I? Or did I forget to add them? No, they're right here. Okay. I was worried I forgot to change something. Git diff. Yeah, so we added the bools because we're refactoring for this toggle thing. Okay, that's good. And this was the one I messed up. All right. So in this file, we're going to parse the file just like we did for the other one. So it's the same thing with 2016-12. It's, oops, 16-12. Oh, we can blow this away now. Right. That goes away. And it's just basically these same lines here, right? And put that in the parser. And instead of 12, it's 23. And now I should be able to Oh, I got to use it, right? And where's this line here? Self VM push. We don't have VM yet. So I need to say VM machine. Oh, machine might not have a default. Oh, it does. Oh, it panicked. Invalid digit. That was assembly line 16. Okay, let's find assembly line 16. Oh, interesting. Interesting. J&Z now has a non... Oh, that's new. That's new. Right there. It can be a register. Okay, so that's new. We have to change that. Which means we have to do a register parse. Unwrap. And now, of course, in order to execute it, we need to handle the destination. Let dest equals match dest. Source reg r as usize. So it's basically the same thing as source val v va v. Oops, I left an L in there. It does? I was doing the same exact thing. Oh, maybe this is wrong. That's a source, and that's a register. Oh. So how do we handle it with copy then? What am I doing? Oh, I split it out into two different ways of handling it, right? But then dest is a register. Oh, it's a source, which means we have to do a source parse. Which means we don't do star dest, we just do negative dest. Okay, and then we have to run day 12 again. Make sure we didn't break it. Yep, those numbers look right. Okay, so now we can parse, and now we just need to execute. Okay. What do we need to do now in order to do the toggle? We can look here to see, are we toggled? In order to do a toggle, what was that? Let's do that. And that way we can actually try to execute the thing now. We can say in 2016, 23, which doesn't exist. We can say VM run, I guess. Oh, what's the output we're looking for? What value should be sent to the safe? Final value register A is 3. Register oh, okay. The electronics put 7 in register A. Okay, so we can do that. Can we? We should be able to set register A, right? Oh no, we give it a first C. So we should have a machine.setRegister, right? So we can, and then set the value left in register A to the safe. And we are returning the value in register A here. So we can just get that value as the return value. But we do need to have this refactored. I'll refactor that in a second. But right now I'm going to say pub fn set register R register and V value. And that's going to set, that's going to set the register, but now that's not good. I can't set a register because the registers are internal to the run command. What's a better way to do this then? I think it's, instead of doing this, we can have an initial register here, or a vector of registers to set would be cleaner, I guess. Initial state is a vec of register value. Like that. And then instead of setting first C here, we set all these to zeros, and then we say for I in initial state. And then this is a register and an I32. Then we say reg of I.0 as usize is equal to I.1. And then we come back over here and go to 2016-12. And then instead of saying first C, we say vec bang of register C gets set to 0 and 1. Is that the way to do that? It built, and those are still correct. Okay. So now we can set any register to any value at the beginning of a run. And I keep deleting my buffer that has the code I want. So now I should be able to say, run this, and it should panic because the toggle command now panics. Self VM run vec bang register A 7. Oh, that's a tuple. Should be a tuple. Like that. There we go. Yes, it panicked. Toggle a register C. So perfect. So it got to that point. All right. So now we have to figure out how to toggle the commands. Oops. Let's see if I can do it without losing my buffer here. So if ink is toggled, it becomes a deck. If deck is toggled, it becomes an ink. Should we just generate a new instruction? Maybe that's the way to do it. Let I is equal to if self prog old IP dot something. We just want to look at the first. We can just say is toggled, right? And we can write a little thing that generates that. So if it's toggled, then we can Oh, yeah, we can actually have this do the generation and just return the toggled version of it. Oh, I did it again. There we go. Right? So we can just say get inst bubfun inst self if self dot 0, which means it's toggled, match self, right? And then if it's inst inc, it becomes dec. If it's inst dec, it becomes inc. And then I have to do the other ones. Otherwise, it's just self. And I'll say return a reference to self because, oh, I can't do that because I want to generate new ones. And here I want to clone. And this becomes a to-do. Does this build? Oh. Oh, right. I have to extract the first bit of... It's not self.0. Can I say if matches bang? No, I can't. I want to be able to say, does this instruction... Is this instruction's toggle reference set? And maybe we need to do like a struct thing instead of an enum. Match self. I can do this. True something something. And instead of else, it just becomes this. Does that build? I missed a brace somewhere. That one's right. That one's wrong. Here, I forgot it here. Okay. Oh, oh. So I have to do it for each one. Okay, inst inc true r becomes inst dec false r. And then inst dec true. Why did it take me so long to figure that out? And then to do, and then, oh, everything else becomes clone. Okay. Oh, we have to clone these guys too, because these are all going to be brand new instructions. I wonder if I should just do that as we parse and insert. We can either say we can have either one. That's inst. That's inst. That's inst. Oh, we're cloning the reference. Do I need to do that? Yeah. And instead of this, we want to get inst. We want to say inst.inst. Okay. Inst. And now it doesn't like this because we can't clone that. And this also needs to be, oh, it already has clone. Okay. So now line 115, it panics. Which we're expecting, right? Because we're not handling the toggle yet. But we should be handling the toggle now. We should, we need to be able to now say, modify source. So source is a source. Right, and then we have to say self prog dest equals not self prog. Oh. I want to toggle the and you can't do that, right? You can't change, you can't modify a tuple. Maybe I can say no, I can't. All I'm trying to do is toggle this thing. Maybe I toggle it in a separate array. Maybe that would be an easier way to do it. Instead of having these things here, I store the toggle ability in memory. I'm going to try that now. And then inst becomes, we get rid of this. Because in the machine, we'll say vec and then prog and then tog vec bool. And that'll start off as all false. And then what we'll do is we'll say, oh, I want that. I did want that toggle inst. So I want to say if self tog old IP, then self prog old IP dot toggle, else self prog old IP. Right, and then say let inst equals, and then this just becomes inst. And now I have to write toggle, which I was in the middle of doing, and I broke it. Right. Okay, so let's do that now. And that way we can just write a toggler. Here's parse. So after parse, we'll do toggle. Pub fun toggle. Self. And that's what we were in the middle of doing. Okay, so match self. If it's an inst inc r, then it becomes an inst dec r clone. Inst dec r becomes an inst inc r clone. And then we have j and z becomes copy, right? Inst j and z of source dest is equal to inst copy clone d a clone, and then inst copy source and dest becomes inst j and z source clone dest clone, and then we have inst toggle, and this is a single instruction. So as for a single instruction, all other one argument instructions become inc. So this becomes inst inc, and the compiler is going to tell me which one of these doesn't map properly, and then we'll have to fix that. And that's all we need to do. Yeah. So this is a mismatched type. Because we don't expect to copy into, that says a source and that says a register. So I need to be able to do a source here as well. And then in the copy code, where we handle the copy, if dest, and it says unknown now, because I broke something else. Oh yeah, because this has to be a source. Oh shoot. We have to ignore it, right? And that's here in the copy code. If dest is, that's still unknown. Wow. R clone, yeah, so this, everything has to be a source. And I have to rename that now. Source. It does simplify this code a bit, doesn't it? Oh yeah, and I got to get rid of these things. I forgot about those. Okay. And now R as usize doesn't work. You can't say source as a dereference. We have to say inc source reg R and ignore the inc oh, but I can do that? Yes. Okay, and then do the same thing here. Source reg R. That's interesting. The other way around, it makes it a and now dest. So copy. Dest has to be, it was a register. Right, source reg dest. Oh, it changed because I'm okay. I'm copying it there. Okay, that's why. Source reg dest. There. That, and that. That and that. And now everything else blows up, right? Okay. Because we're missing, we want to ignore anything that, yeah, this is bad, right? Because now it's not going to tell us if there's something wrong. I'll clone our way out of that problem. And now we have something we're not using, 121. Oh yeah, we haven't been toggling things. Okay, so now all we need to do is say self tog of dest is equal to not self tog of dest. And that'll toggle that instruction. Index is out of bounds. Oh, right. So if dest, oh, right. So every time we push a new instruction, I forgot. Every time we push a new instruction, we have to push a new toggle bit. Self tog push false. It's taking too long to run now. I should not have run it in Bacon. I should not have run it in bacon. Let us kill it. And so it's just taking forever to run because I have a bug somewhere, which is a shame. We can print out the instructions as we get them. Print toggled and print normal, and then we can say println inst, and let's quit out of bacon before I do that because we have an infinite loop somewhere. And so now we can do a cargo run less. Okay, so we have a toggle somewhere, and there's a TGL. There it is. All right, so what we should do actually is run the test code here and see if this works. What I've got a feeling that's happening somewhere is that we're not ignoring something correctly, or there's something that we should be handling that we're not supposed to be. All right, so let's quit out of this. And let's run the test program. We can say this here, and then we can just say let lines is equal to this code here. We can put new lines between each one. Oops. Like that, and that should be able to be parsed for L and O. We want to say split on a new line, map s.toString, collect vec string. All right, and then I should be able to say cargo run, and it should just run that smaller version of it. Okay. So let's see if this does the right thing. Copy to A, initialize register A to 2. Oh, I should print out the contents of the register after executing each instruction, right? So we can see the result of the... Yeah. So println bang space 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 reg : ? Okay, let's try again. All right, so put 2 in A, right? The first toggle A causes the instruction at 2. Instruction 2 away from it, which changes... Oh, 2 away from it. That's what it is. That's what it is. I was just taking it as the index. It should be old IP plus dest. That, and right, and we have to do the same weird logic here. We have to do the same weird logic here. So we have to say this could be a negative number. So this could be as I32, or it already is an I32 if I do this. Yes. So we want to say if dest is less than 0, and we want to do toggle old IP minus dest else self tog minus dest as usize. Why don't we just do that? Old IP minus dest as usize, or it's old IP plus dest as usize. And then this will be the location that we're going to toggle. Okay. All right, let's try running that and see if that's closer to what it's supposed to be. All right, the first toggle A toggles instruction at 2, which we don't see. The second toggle also modifies instruction 2 away from it, which changes the copy 1A into a J and Z 1A, which doesn't do anything. The final value in register A is 3, so that's correct. So we were able to ink A using the toggled ink, and then the J and Z register A jumps A instructions ahead, skipping the deck instruction. Okay. So maybe this will work now with the real data. Let's find out. Oh, it panicked. On line 134. Oh, this probably... Yeah, so if lock is less than self-tog len. Right? Because it said ignore if the toggle... Yeah, the attempt is made to toggle an instruction outside the program. Okay, so that's that one. So let's find out now. It finished. It got 12,800 as an answer. Let's see if that's the right answer. Yes. Okay, brilliant. That means we can delete all of this stuff about printing things out. We can go back to Bacon for running it. It runs pretty quickly. That's good news. Let's see what Clippy says. Clippy likes it. Git status. Git add input. Git commit. -m 2016 day 23 input. Git add source. Git status. So we should still have that original, yeah. Git commit -m 2016 day 23 part 1. What's part 2 going to be? Cargo run 2016 12. Cat original. Okay. So we didn't break day 12 either. That's good news. Yeah, and so let's take a look at part 2. The safe doesn't open, but it does make several angry noises to express its frustration. You're quite sure your logic is working correctly. So the only other thing is you check the painting again. As it turns out, the colored eggs are still eggs. Now you count 12. What does that mean? Oh, that's the input. Okay. As you run the program with this new input, the prototype computer begins to overheat. You wonder what's taking so long. Oh dear. I wonder if there's some optimizations we have to do. I don't have time to do optimizations. I'm already over time. So nvim. Let's just try to run it with the new input of 12. And before I do, that's in Clippy. Okay, before I do, I'm going to cargo run release, just in case. Oh, okay. What was I worried about? Let's see if that's the right answer. It's not the right answer. All right. So obviously I messed up something. I'm going to have to do part 2 tomorrow because I am out of time. So we run it once with 7, and then we run it again with 12, right? Because the way this worked was we had 7 for the first input and then 12 for part 2. And this was the wrong number. So we have to figure out why that's the wrong number. Let's take a look at the machine itself and see what's going on here. So all we do is run it a second time. And it worked for the first time, so it's not like there's instruction problems. Here's where we execute the instructions. Here's where we figure out if we're toggling an instruction. How do we know if an instruction is toggled? Because we have a vector of booleans, and I see what the bug is. Okay, the bug is that we're rerunning this machine without resetting the toggle bits. So should the toggle bits just go away? Or we could just reset them on a run? We're creating the, yeah. So we don't need to do this then. What we can do is say, when we start our first thing, we initialize all the registers, and then we can say self tog is equal to vecbang of false semicolon prog.len. And that doesn't work. Self prog.len. Okay. It's running. It's taking a long time. This is taking a very long time. What I'm gonna do is I'm gonna quit out of this and cargo run release, and see if we get a number in less time than. Ooh, I wonder if I have an infinite loop somewhere, because it feels like this should have exited by now, right? Oh no, we got an answer. It just took 10 seconds in release mode. Let's see if it's close to being right. And that's the right answer. Okay, so that was the bug. All right, so we're done with day 23. So that was the bug. Let's what am I doing here? Right, so the bug was that I wasn't reinitializing the toggles, and was assuming all toggles get set to false at the beginning of the program. Okay, so that's all we had to change, that one line, get status. Oh, okay, so this is all apparently, all right, and then I had the original day 12 answers here. Let's keep it for now. Let's keep it for now. And you know what I can do is I'll do this, and I'll say, I'll call it output, and then I'll modify the get ignore to ignore anything to start at output. This is, there we go. So git diff, where were we? Return to your advent calendar. Okay, so we're just comparing this here. I've changed this for part 2. I changed this for part 2. I deleted that line, and then I reset everything. Okay, so very simple. Okay. Git add, git ignore, and source. Git commit -am 2016 day 23 part 2. Okay, good. Let's start day 24.